All right, so we're going to solve some application problems with the law of sines. So just really quick, law of sines, which was shown in another video, it looks like this. Okay. All right, so this problem says to measure the length of a lake. Points A and B are marked with flags at the opposite ends of the lake. A third point C is marked by walking 125 meters from point A at an angle of 41.6 degrees to AB, line segment AB. Angle C is measured to be 124.3 degrees. How long is the lake? So let's draw a diagram here. So if we have this lake here, and we'll just say this is one end here, and here's the other end. And then so I'm going to go ahead and make my point A here just because I have a little bit more room to work with over here, but it doesn't really matter when you draw a diagram. And then it says that there is a third point C marked by walking 125 meters from point A. So the question is like which direction you go. You might have to just do a little trial and error. But if I went like this and then marked it, that would be okay. Except it does say that angle C is 124.3 degrees, which that would not be 124.3 degrees. It doesn't really matter. You don't have to draw your diagram to scale, but just to make mine look a little bit more like the situation, I might draw it like this, and I think we'll get a little bit more of a possibly obtuse angle. Not really, but that's okay. It doesn't really matter. Okay, so we'll say that this is, so this is a, where flag C is here, point C. And so that's 124.3 degrees. All right, and then it said that this angle here was 41.6 degrees. Okay. Yeah, it had a 41.6 degree angle to line segment AB there. Okay, and then this is 125 meters. Okay, this distance here. Okay. And so we need to figure out how long the lake is. So that we'll just call that little c. Okay, this will be big C here, and then this is little c. Okay, so well, we have we're going to need, in order to use the law of sines, we need an angle measure and the opposite side. Do we have that right now? Because we're going to need at least, out of 4 pieces of information here, we need to know 3 of them. So we're going to need at least an angle on the opposite side. That's usually how I start these problems out. Well, looking at this, well, we don't know angle B. We have this side only, and we don't know angle B. So we don't have an angle on the opposite side. However, we do have 2 angles in the triangle, so we can figure out angle B just by using the triangle sum theorem, which says that all angles in a triangle add up to 180 degrees. So let's do that. We're going to add the 124.3 degrees to the 41.6 degrees, and so that comes out to 165.9 degrees. And then we're going to take that away from 180, and that will get us what angle B is. So just using my calculator here just to make sure I don't make a mistake. So 180 minus 165.9 comes out to 14.1 degrees. All right, definitely not to scale. Okay, that's more than a 14-degree angle, but it doesn't matter. We're still going to be able to use the diagram in order to solve the problem. Okay, so there's that, and now I do have a side and the opposite angle, and then I want to figure out C here, so I'm going to involve that. So my setup is going to look like this: sine of angle B over B, side B, right? I know those 2 things. And then I want to find C, so I'm going to involve that part of the law of sines, like so. And now we just plug in what we know here. So sine of B, B is 14.1 degrees. Side B is 125. And then C is, sorry, that looks a little messy. That's going to bug me there. Okay, there we go. Better. So sine of C is, C, angle C is 124.3 degrees. And side C we don't know. Okay, so now we cross multiply. So C times the sine of 14.1 degrees equals 125 times sine of 124.3. Divide both sides by sine of 14.1 degrees. And so that will be our answer, whatever this comes out to. So I'll go ahead and put that into my scientific calculator here. So 125 times the sine of 124.3. Make sure your calculator is in degree mode. Mine is, you see right there. And then divided by sine of 14.1. And so I get 423.8. We'll go ahead and round to the nearest tenth. So actually it'd be 423.9. Meters is the unit here. Okay, so that's how these work. Okay, you guys go ahead and do numbers 3 and 4. Okay, so this is what I got on the Grand Canyon problem. You just have to read these really carefully when you make your diagram. All right, so yeah, this was the diagram, or something similar to it. If you went the other way here, drew the triangle the other way, that would have been fine. A and C just had to be on the same side of the canyon. All right, so probably not actually realistic for the Grand Canyon, 184 yards. That's not really a very long distance. But so at first I did double check my answer, and I'm like, yep, that's got to be it, after I went through my work again. But yeah, probably not. If you look up the length of one side of the Grand Canyon to the other, it's probably a lot more than that. Okay, so then the flagpole problem here, we had a leaning flagpole. When I was interpreting this problem, I thought, well, is the wire, is it going to be holding it this way or holding it this way? Maybe the wire's pulling it down. That's why it's laying to its side. But then I thought about it. Oh, wait, if it's longer, if the wire's longer, then it's got to be on this side. If it was here, it would actually be shorter. So that may not affect the outcome of the problem either way. I'd have to think about that. But yeah, it would make sense to draw the wire on this side. Because this is the only way it can be longer than the flagpole. All right, so I set that up, and then I didn't have I needed angle C here, and I didn't have side C, so there's no way I was going to directly solve for angle C. So I had to actually find angle B first. So that's what I did, and then I got angle B, and then you can just take away angle A and B from 180, and you have approximately what angle C is. It's approximate because I rounded B, so since I used a rounded value, that's why I wrote my approximate equal to symbol in there. All right, so there's angle C.